Now let's look at the end behavior of log functions. So the first thing we have to do is we have to make sure that we know what we mean by end behavior. What we mean by end behavior is what a function looks like as x gets very large or very negative. So in general, if you have a function let's call this k of x. If you notice here, as x gets very, very large, positive, then the function kind of piddles around here, and then when x gets large, it keeps increasing and increasing and increasing. So we say as x gets very large, y goes to positive infinity. Now, as x goes in the other direction, as it goes toward minus infinity, it also behaves a certain way, but in this case it gets closer and closer to some number. In this case, an asymptote at x is equal to minus 2. So that's what we mean by end behavior in general. And the way that we describe end behavior is we use what's called limit notation, and that's the limit, in this case, of k of x as x goes to infinity, and the limit of k of x as x goes to minus infinity. And that's the answers to these two questions is the end behavior. It turns out with logs are pretty simple in end behavior, if you think about it. This is a generalized log function. There's an asymptote. It only has end behavior in one direction, right? In some sense, as x goes to positive infinity. In the other direction, it gets closer and closer to some asymptote. So you have to find that asymptote. And that's what happens at the ends. So let's look at this. Let's look as an example. Let's look at f of x is equal to 3 plus log 7 x minus 5. So the first thing we want to do is we just want to sketch the graph out and pay close attention to what the asymptote is here. Well, the asymptote starts out at x equals 0, right? The basic log function, the asymptote is x is equal to 0, and it looks like this. And then we're going to possibly flip it around and shift it left and right. This one shifts up 3, and it shifts a positive 5, a right 5. So the asymptote starts out at x equals 0, and it moves up 3, it doesn't change it, and it moves right 5, it does. So the new asymptote is x is equal to a positive 5. And we can see what the graph looks like. 1, 2, 3, 4, 5. There's an asymptote. This one doesn't flip. It looks generally like this. And now we can figure out what the end behavior is. The limit as x goes to positive infinity is pretty clear of f of x. As x goes to positive infinity, y goes to positive infinity. Now, on the other end behavior, x doesn't go to negative infinity. It only goes as far as x is equal to a positive 5, right? The asymptote, the new asymptote is x is equal to 5. So it gets closer and closer to 5. It doesn't reach it, but as x gets closer and closer to a positive 5, what happens to f of x? It goes to minus infinity. And that's the behavior at the two ends of the function. Let's do another example real quick. Let's do g of x is equal to, in this case, let's do 7 minus log 4 x plus 3. So we have the basic log function. We know what that looks like, but this one actually is flipped. So let's remember, y is equal to minus log 4 of x is going to roughly look not like this, but like this, right? It flips across the x. That's a reflection across the x-axis. Let's see what the new asymptote is. The asymptote starts out at x equals 0, It moves up 7, that doesn't change it, and then it moves to the left 3, negative 3. So the new asymptote is x is equal to minus 3. And that's the asymptote. It's going to roughly look like this. We don't know exactly what it looks like, but that's going to be good enough for this. And now let's look at the end behaviors. Again, the end behavior as x goes to infinity is pretty straightforward. As x goes to positive infinity, then g of x, in this case, goes to, well, it goes to negative infinity. The other limit is not as x goes to minus infinity, but as x gets closer and closer to the asymptote. In this case, the limit is x goes toward minus 3. As x gets closer and closer to minus 3, y gets closer and closer to a positive infinity. And that's your asymptote there. So what you do is you notice, if you notice in both of these problems, right, we have the answers are always going to be either positive or negative infinity. The limit is, one of them is going to be as x goes to positive infinity, the other one is going to be as x goes to the asymptote. Let's do one more problem, which is maybe one of the harder problems that we've done. Let's do f of x is equal to 4 plus log 9. Let's do minus x plus 3. So we have to remember what y is equal to log of minus x looks like. We don't see that very much. Remember, that's what log x looks like. So if it's log of minus x, it's a reflection across the y-axis, so it looks like that. So that's your basic graph of y is equal to minus x. Y is equal to a log of minus x. Now what we're going to do is we're going to take this entire thing and we're going to move it 3. It's a positive 3, so we're going to move it left 3, and we're going to move it up 4. So the new asymptote, remember the asymptote doesn't change with the 4, it's going to change with the 3. So the new asymptote is x is equal to minus 3. You might want to be a little more careful in this problem, a little more difficult, right? Here you have the asymptote. The asymptote is x is equal to a minus 3. It's not going to be over on this side because it's the negative inside the function, so it's going to roughly look like this. The function is going to move up 4. It's not going to change the basic graph. So that gives us the basic shape. Now let's look at the limits. First, x can go to minus infinity in this case, right? As x goes to minus infinity, let's see what happens. As x goes to minus infinity, y goes to positive infinity. And then in the other direction, x is going to get closer and closer to the asymptote. In this case, the limit of f of x, as x gets closer and closer to minus 3, is going to be a minus infinity. So the basic pattern still holds. The answers are going to be infinity and minus infinity in some pattern. In this case, rather than going to infinity in the asymptote, you're going to go to minus infinity in the asymptote. And that's how you find in behavior of log functions written in HK. And we're done.